So to describe the radius of convergence, the interval of convergence, we are talking about the possible value for your series, well, all possible values of x for your series to be convergent. When it is outside this interval, you're talking about your series, your power series will then be divergence. So if you have a series that is center at 0 or center at any point with x equals a, then the radius of convergence will be the radius that go from one side to the right or from this center point to the left. And the interval between these 2 points will then be the interval of convergence. So we can always use the ratio test to look for the radius of convergence. Of course, sometimes we can use the infinite geometric series to check for the interval of convergence, given if you have an infinite series. Let's say you have 1 over 1 minus n. With the ratio here, then you want your ratio to be less than 1. So technically, it is just the ratio test. So in example number 2, if I have a series, an infinite series, and I want to find the radius of convergence, I can once again use the ratio test, try to solve for x, and once I'm done with the ratio test, don't forget to check for the endpoint. So first of all, ratio test. Find the ratio between the two, and then we will take the limit after that. So for the first part, I have n plus 1 times x plus 2 with n to the, well, with power n plus 1 divided by n to the power of n plus 1 here and plus 1 there. So overall, you have n plus 2. This is just for the term n plus 1. And I will divide it by the nth term, which is just the expressions from the question itself. And once you take the absolute value, simplify your expressions, you are going to end up with something that is relatively simple. Like if you were to look at this and that, once you reduce it, you are just going to end up with x plus 2 in the numerator. And also, if you compare this part here and that part, after you reduce these two terms, you are going to end up with just a 3 in the denominator. So after I simplify everything, that n plus 1 from the first part divided by n, which is here, will be part of your ratio. And after you reduce the x plus 2 here and there, we will end up with x plus 2. And of course, the 3 here and there, after you simplify everything, we will just end up with a 3. And if you were to take the absolute of this entire ratio, knowing how all the n's are positive, the absolute value only applies to x plus 2. So taking the limit as n tends to infinity, the ratio between the n plus 1 term compared to the nth term would just be the limit of this. Now once again, using the L'Hopital's rule, seeing how we have n here and 3n there, the L'Hopital's rule will simplify this entire expressions to 1/3 with the absolute value of x plus 2 here. So using the ratio test, if I want my ratio to be less than 1, well, to make this series converge, we want limit less than 1. So making this less than 1, we are getting an expression that look like this, which means I have a series center at -2, which is quite obvious when you look at the question itself. with the radius of convergence equals 3. So solving for x, I probably will have anything going from -5 to +1. But this is not the end yet. We need the end point. When x equals -5, I want to substitute this number back to the series and see whether it is a convergent series or divergent series. And I can make use of comparison test, integral test, or the alternating series test to check for its convergence. But let me just plug in the number first. From n equals 0 up to infinity, when x equals -5, I will have -5 plus 2 inside the bracket raised to the power of n divided by 3 to the power of n plus 1. So if I can simplify it a little bit, seeing how we have different exponents for those two, if I can do a little trick so that everything goes under the same exponent, it will be a lot easier to manipulate. So in this case, I'm going to consider this as having 3 to the power of n times 3 to the 1. Or technically just having 1/3 bring to the outside. And also, with a negative inside the bracket, I can actually rewrite this as -1 to the power of n and 3 to the power of n. So now everything got reduced to something really simple. -1 to the power of n, and you times it by n. So you are getting an infinite series that goes from +n to -n, alternating between the numbers. And as n tends to infinity, this is going to diverge because of the n here. So at x equals -5, we have a divergent series. And now I can try the value again when x equals 1. Substitute x equals 1 back into the question. Once again, here is the question. With x equals 1, I have 3 to the power of n, and here divided by 3 to the power of n plus 1. And using the same trick that I did, the denominator, n plus 1, let me turn it into 3 to the n times 3. And now, like terms get reduced, we are looking at 1/3 summation of just n. Now once again, as n tends to infinity, you are getting a divergent series. So both endpoints for this series will be divergent, meaning the interval of convergence of this series will only go from -5 to 1 with a radius of convergence equals 3.